Welcome to the demonstration lab. Today we're going to talk about specifically the temperature platforms that are available on the transient plane source and the transient hot wire. Again, this is our MP-1, which is our advanced method of measuring thermophysical properties for solids, liquids, pastes, and powders. Each MP-1 has a 4-channel switch that lets you connect multiple devices to it, and the temperature platforms are one of those devices that allow you to test cooling and heating. Before we get into that, we'll just do a quick turn of the cameras to show you our measurement platform series. That's what MP stands for, is measurement platform. So we have our advanced future-proof MP-1, which is our most really packed full of features and technology. We have our mid-range MPV, which is developed to meet the typical needs of somebody measuring thermal conductivity. Again, solids, pastes, and powders, and liquids, or with the transient plane source and transient hot wire. These are the two integral methods to all of our MP series. Of course, other methods of TLS can be added to all the MP series as well. So the mid-range really is our most popular MP. So for TPS and THW. And then our portable. So for economic, it follows all the same principles of operation. We have transient plane source, transient hot wire for liquids. So again, transient planes for solids, pastes, and powders, transient hot wire for liquids, both following international standards. So very accurate. Make the measurements on the controller. You can export those to Excel and review it. Just more limited range, which makes it more economical. Of course, it's portable. So we're going to talk about the temperature platforms and their temperature range, basically, the options on the cold side. So for the TPS, this is our transient plane source temperature platform that allows you to measure this basic one with no external cooling, goes from 0 to 300 Celsius. And the transient hot wire has a basic temperature platform as well. The cold side of both of these can be expanded below 0 degrees. So on the TPS side, it can go to minus 45, which is the combination of a chilled circulator and thermoelectric boost. So inside of here, we have a more powerful thermoelectric stack along with a chilled circulator. So the temperature range, so on the same platform, you can go from minus 45 to 300 Celsius. And we're going to talk about the next lowest temperature, which is minus 160 to 300 Celsius. So we're going to go over here. So we've assembled an MP-1 just to show what the setup would look like. What are the components of the device? So this is a 50-liter dewar that's good for about 24 hours of operation. There's a valve with an auto set temperature feed, and it works off the principle of liquid nitrogen flow, exhaust flow. So it's all within the same small footprint, so it allows you to connect to the same controller. And this goes to a lowest temperature of minus 160. We use the exhaust from the dewar tank. We get a nitrogen purge, which helps control moisture buildup. You can also do that with a dry air feed as well on the temperature platform. But ultimately, what is really nice about this system is with one setup, you can achieve ISO steps of temperature from minus 160 to 300 Celsius, all within the same schedule. So it's all fully automated by the MP-1 software. So it really allows you to expand the use of the instrument. Now this is something you can add down the road. So if you only have a room temperature MP-1 and you want to add this temperature platform, or even 2 platforms side by side, you can do that because the MP-1 has 4 channels. So that's the setup. A dewar, we have a valve line that's controlled by this control box, and this is the liquid nitrogen goes through a closed loop or a loop inside the temperature platform and exhausts out, and the unit benefits from that cold side. Very fast, controlled temperature, and accurate set temperature. So maybe what we'll do also is just show you a quick sample setup of the temperature platform to help sort of bring that full circle. So this is your TPS sensor, 4 contacts. We're going to put those into the 4 contacts of the temperature platform. So all the sensors can be used inside a temperature platform or a room temperature sample holder, so it makes makes the uses of the sensor quite flexible. We'll secure those electrical contacts. So now the sensor is set electrically. The floor of the temperature platform can go up and down to accommodate different thicknesses. The maximum thickness on the temperature platform is 20 millimeters. The maximum diameter is 40 millimeters. Now, of course, it does not have to be a round sample. It does not have to be a specific height. It's just those are the maximum dimensions. So that floor goes up and down to accommodate thin films and slabs and different shapes and sizes. If your samples are larger than this, we have our standard room, our sample holder that can go up to 300 Celsius, which is 4-inch square by 2-inch. So you can use that if your samples are larger than this. But we find this accommodates most R&D development materials. So if you're running symmetric, you place one on the bottom, one sample half. In this case, we're measuring stainless steel, sample half on top. If you were running asymmetric or single-sided, you would introduce a unknown material, which we provide with the instrument. Rather, you would introduce a known material on the bottom or top, and then you would introduce your unknown material to the other side. So your sandwich would be known material and your unknown material on the other side. This top piece closes the heating side of the sample cell. So we secure the sides. That creates a clamping pressure between the two sample pieces. This is where the heating comes from. This closes the cold side. So inside there you have heating and cooling opposing each other. This cold side goes to the lowest temperature. So in this case, this cold side would go to -160. So you always have this opposing cold side, and that gives you very fast response when you want to go from hot to cold. So you can have very nice control of temperature. And then this is your safety lid, which has a magnet which will tell the instrument that the lid's on or off just from a safety point of view. And that's your sample setup. So that gives you a kind of a quick view of the sample setup, but more importantly, the liquid nitrogen system that we've developed. It's very small footprint, very fast, very convenient, ground up developed for the measurement of thermal conductivity so that you benefit from that unique set of features. Thanks for joining us. We'll be having more demonstrations in the future.